So if you guys, so yeah, if you guys have questions, please ask. We're going to do the quick overview of the FlexCNC, and I want to go over some customer application examples, just to help you guys understand how we're helping shops, and we're going to go into more details about that. So ask questions as we go through. Just unmute and ask, and/or you can raise your hand, and I will call on you, just like back in school. So let me know if you can see my screen.
Yes.
You can see it? All right. Move this here. So this is the quick overview of the machine. Obviously, everything we do is really long, like you can see in the picture here. So our machines start out at 20 foot long, and they only go longer. We're ideally built to machine in hard materials such as steel, stainless steel. That's why a lot of our customers select us. It's so they can have the versatility, the flexibility. So they can do steel, aluminum. So that's rigidity is never something that's going to hold them back when using our machine. So our brands, FlexCNC, FlexBeam, FlexArm. Mostly everybody knows us from the FlexArm name. That's a machine tool we've been building for the last 40 years. Quick timeline, I'll breeze through this quickly. I know you guys know us pretty well. So obviously government contracting in the beginning, started building the FlexArm machine tool. Since then, we've really developed that to do big hydraulic tapping, custom part manipulation, and today it's into the machine automation with the CNC machine and beam line. Core values, guys, I like to touch on this because what's near and dear to most of our customers' minds is bullet point number 4, where we're going to continue to and always bend over backwards to make sure customers are always happy and we're helping them. So, but this defines the company. It's how we evaluate and keep each other accountable. So it's something we all work on, and it's what's allowed us to get to this point of where we are today. So our mission, in a nutshell, it's to be the #1 CNC machining solution for fabricators. So right there in the middle, the machines that with that FlexCNC and the beam and the tapping arm, we really focus on the fabrication market, and where we want to be is the #1 CNC machining solution for fab shops. And with the solutions that we provide, we think we can be there, and that's where we're going to be. That's where we're going with the machine. Quick snapshot of some of our customers. Some of these you'll recognize. Some of them are FlexCNC customers, some are FlexArm customers, but it just shows you the diversity and all the customers that we're helping save money in their shops with our technologies. Snapshot of customers using the FlexCNC in the United States. And some actual applications. So this is a good example of a customer who bought one of our CNC machines, and we turned a fabricator into a CNC machinist. So using our service and support, we bend over backwards again to help customers out. And this was this testimonial really summarizes that well, because it shows what we were able to do with a guy that was a fabricator, and you can see some of the examples of his work. And this is what he's doing with the machine now. So a huge testament to all our guys, our programmers and our trainers. But this is what customers can expect when working with us when they buy one of our machines. We're going to help them do all the programming and the training. Another customer application, I like to share this one because it just shows the length of the machine and where we were able to satisfy a bridge when they compared us to a tube laser. So this customer, prior to buying our machine, was processing this material mostly by hand or feeding it through machines in multiple stage setups. And when they bought the machine, this is how we're able to chuck up any size tube, index it, mill it, drill it, tap it, and they work automatic. The program works in conjunction with the pneumatic clamps that we built. So clamps open, part indexes, clamp close, all automatically with the program.
What's the OD limitations as far as max OD, fourth axis?
Yeah, that's a good question. So maximum size of pipe. So these guys, they can run up to a 16-inch, and anything bigger than that, we can go bigger. We just have to either lower the machine base or raise the gantry. So, and that is a good point. I mean, we customize these machines and we build them to order. So this is a good example of that, where we actually lowered this machine bed 3 inches to allow for them to chuck up bigger pipe, and built this machine 35 foot long. So
Okay.
but the bigger story behind this one is, I was touching on it earlier, is more with the tube laser comparison. So this customer was looking at a $3.5 million tube laser, and we were able to provide them a solution for right around $400,000. And so we were able to save them a ton of money, and they were able to process the tube almost just as efficiently. And it gives them a ton of flexibility to be able to run their small diameter parts all the way up to their 16-inch diameter parts. So, and that's where with the machine, and again, before, these guys were running this either by hand or manually feeding it through operation. So that's the bridge that we're gapping with this machine, and the alternative that we can provide against other technologies out there too. So I like to go into a little more detail too, because a lot of tube lasers, you're $1 million+ first of all to acquire one. And there's typically a diameter limitation where I can only run up to 10 inches or 12 inches. Or if I want to run a 16-inch, you're going to spend over $3 million to acquire that tube laser. So that's where our machine provides a nice alternative for the big tube. So anything 10 inches or bigger, we can cost effectively chuck that up on this machine and run that for those companies. So that it gives them a really big competitive advantage to run the bigger tube, bigger parts, and all the machining value add that our FlexCNC brings to the table.
Yeah, and that's what I was going to say. It's that you also get the flexibility as far as for the machining capabilities, not just hole making.
No, yeah, exactly. So, and that's always a big point to remember. It's with this machine, it's so unique and so new to the market. What it does is it gives shops a competitive advantage where they never thought they could have had it before, just because of the length. It's typically we're 20+ foot long vertical machining center, and it just that gives them more capabilities than a lot of their local machine shops. Another customer example, these guys, they do a lot of long parts, steel and aluminum. This is just a short video showing you some simple hole making along the part, but Wagner's story is pretty cool because, again, before our machine, they were running these parts with gang drills. So super old gang drills, pushing the parts through manually, and it was obviously super inefficient and not a 21st century way to do those parts. So they bought a really long machine. They specifically picked us just because of the length, and we were able to provide them a super, a really fast way to process the way that, to process these handrails. But yeah, I just like comparing it again to show that bridge that we're gapping. Before they were doing this with a gang drill setup, and we came in with this machine and can offer them a really nice solution to modernize their capabilities. So Century Equipment, this is a cool application that we have been coming across a lot lately, and it's for form drilling. So this company specifically is thermal drilling, form drilling, flow drilling, whatever you want to call it. But they're doing it with our machine. They bought it because of the length, and they have our machine placed right next to 10 other Mazaks where they do smaller machining. But here they're able to chuck up long stainless steel pipe and tubing and do all their form drilling and form tapping with the machine. So I like just talking about it because it shows a different process. More and more folks are getting into the form drilling, and we have some pretty unique features built into our machine that allows you to form drill really well with it's a Z-reader probe, which touches off on the material. automatically and compensates for Z. And then obviously with paste and oil systems that work in conjunction with the program.
Before you mentioned that your machines start out at 20 foot and go up, on your website, it mentions a 15 and a 10. Are those available as well? Or is there a reason you said 20 and up?
Yeah, no, that's good. That's a good point. So we have shorter machines, and I always like to make the comparison to shops. I mean, unless it's a space limitation, we can add the most value as soon as we can build you a 20-foot long machine. That's where we're the most competitive cost-wise. For us to produce a machine that's 15 foot long or 10 foot long, there's maybe a $20,000 price difference to build it 20 foot long. So, and at 20, 25, I mean, that's where we can give you a bunch more bed space. You know, you can literally, for $20,000, you can double your machine bed space and give yourself what I like to, it's kind of like 4 machine tools in one, because with all that extra bed space, I can standardize my fixturing across the length of the machine. And there's just, and you have that flexibility now to run those big parts, and it just gives you a huge competitive advantage. So that's where we offer the most value, and our customers are going to get the most for their money, is when they understand the value in having a 20, 25, 30 foot long vertical machining center to standardize their setups, and for that ability to do that one part, those long parts in one operation.
And speaking of your customer, you had mentioned earlier in your vision, defining it as, your vision was to get this to be the best machining center, the most common, and fabrication. Why the fabrication industry specifically?
Now, that's a good question. I like to highlight the fabrication industry because where we're positioning our machine, it's for the fab shop, and it's specifically because those guys run big parts. And at the end of the day, the gap that we're bridging with our machine is it's between a fab shop and a machine shop. So we're that solution where now that company, like the fab shop, they don't have to outsource those jobs anymore. And it's something that now they can run those big parts themselves competitively. And before, even on the machine shop side, what those guys are doing for a 20-foot long vertical machining center, if I need a machine that big, well, guess what? I have to go buy a $1 million gantry mill or a horizontal, and now we can run those exact same parts. Our machine, 20 foot long, you're $200,000. So, and capabilities, we're a full-blown vertical machining center, so we can do those exact same operations and accomplish it for a lot less money. So, and who we're going to highlight there, it's the fabrication shops. They're the guys that at the end of the day, they need a big machine, and they want to do arguably hole making, reaming, chamfering, milling, but we're not machining molds. So we can let the machine shops do that on their $2 million gantry mill or horizontal. Here with our machine, we're able to provide them the big bed and give them the flexibility that they need at the right price. So, and that's why we're going after the fabricator. They're our niche.
So not to say that a machining, a machine shop couldn't be a good candidate, but this would be more of a complement to a standard, smaller Haas machine as opposed to a replacement.
Yeah, no, absolutely. So in a lot of shops, I mean, even we've sold to machine shops, and they're buying it specifically because of the length, the ability to be able to run big parts in one operation, and to improve their quality control, their tolerances. If I have to set up a part multiple times to fit it underneath the spindle, your tolerances are going out the window. And not only that, your profits, because your setup time and all that's awful. So if I can, with our FlexCNC with the big beds, if I can set a part up once and hit cycle start and run it, not have to do multiple setups, then I can be competitive now. Yeah, so machine shops can use it, absolutely, but no, and we have guys that are using it specifically. 24/7, all it does is chamfer or it mills, and that's all they do with the machine. But predominantly, our fabricators, they're using the machine for hole making, reaming, and they get into some milling, of course. But yeah, that's so it's pretty diverse, pretty flexible. But yeah, those are good questions. Did anything else?
Yeah, Nick. What are some of the quality control processes you go through with on the FlexCNC?
Yeah, no, those are good questions. When we bring machines in, we do all the final assembly, and then when we put them together, we're adding the servo motors and the drives, and then we take a Renishaw laser, we compensate each axis, and then we take lastly the Renishaw ball bar, and we'll run a ball bar inspection in there and compensate all the drives and make sure everything's doing exactly what we need it to do. So there's a full-blown checklist that the ops runs through, and there's some sample parts that we run. But yeah, that's that in a nutshell.
What kind of servos do you guys use?
We use Omron brand servos
And drives?
and drives. Yep, absolutely.
Okay.
You guys got anything else? I'm gonna move on. So this is another good example I like to show. This is an example of a customer manual layout, manual drilling. You can see just super slow using high-speed steel drills. I'll watch it again. But this is a classic example of what we're walking into and what this is the bridge we're gapping. Or again, you can see a World War I technology, and then I'll show you how we set this up. That versus this, it's crazy. It's incredible. Hole to hole rapids are 1,200 inches a minute. That's a 2¼ inch drill through the spindle coolant. That drill set up so we can stack these plates. I think that drill is like 8 inches long. But that way you can go through multiple pieces if you wanted to. And it just plowed through there. But that's the difference in that. So those are the things. Those are where we're helping shops out. We're helping them go from this to this. Any questions about that? All right, so I've got this. I like to show this off. This is a little 3D tour of the FlexCNC. This is our factory. Jump right in here. And I'll just show you a quick sneak peek. So this is our crane bay. This is where we assemble all the machines. This is our factory that we moved into last July. But what's cool is it gives you the ability to walk into this tour. You can walk around the machine at your leisure. We can go inside of it, take a look at the spindle. We can watch instructional videos. So at your leisure, you guys can go back through. This is on our website under the G series. You guys can take a look at all the different components of the machine and kind of take a walk around, see if there's anything you like. But if you have any questions, just feel free to reach out after the call. So work holding solutions. This is kind of fun. I like showing these because they're just great examples of how we can do setups. So this is a pneumatic clamp that we've built to work in conjunction with big pipes, similar to that first application that I showed you guys. Here, again, all pneumatic clamps they work simultaneously with the CNC program and the fourth axis. Here we put fourth axes on each end of the machine. So this customer can work in pendulum mode. You can see how long this machine is too. But they're able to work in pendulum mode with a fourth axis on each end. So I can put a 20-foot piece in one end and a 20-foot piece on the other end with the fourth axis and basically just keep running 100% of the time. So that's what we call pendulum mode. Spindle's working 100% of the time. And this is a nice example, again, of where we turnkey a solution from the chuck through the clamp all the way through. These are tube supports. So this is just, again, getting into the turnkey solution, where we can provide that service and support to the customer for as much as they would like us to. So this is where we designed these supports so they could quickly exchange and go from a 4-inch diameter up to a 16-inch diameter part with little to no adjustment. So it's a removable tube support insert. They slap whatever diameter they're going to be running in there. And these go in between the pneumatic vices that I just showed you. And it gives you some support while you're milling and drilling in that pipe. That's just a drawing of the vise. This is what I showed you that was in the video earlier. This is a trunnion. Just another example of something we can source and install in the machine. So we can get as complicated as they'd like. This is a great example. I like showing this. This is where, again, 2 stations. We've got a station over here and a station over here. So we're able to run in pendulum mode. So while I'm machining over here, my operator is unloading the finished parts and putting the new parts on, and vice versa. And then we just keep going back and forth. But I like showing this part off because this is a tool we sourced where the customer wanted us to do everything and turnkey it. So we designed the clamps to hold the material, and we sourced this dual output 90-degree head. And with that head, we're able to access all 3. Basically, we're able to access 2 sides of the part, like you're seeing here in the video. It's basically interpolating, or it's milling that slot. And then with the spindle on the other side, it can mill the other side of that part. And then we park this in the center right here on the machine bed. And then the head can go back and grab vertical tools, other tools out of the carousel and do all the machining on top of the part. So I like showing it for the length of the machine. It shows huge parts, how we're able to operate with the pendulum mode, and how we're able to access 3 sides of a part. So operator puts material in, when they take it off, it's a finished part. We don't have to flip it, nothing.
A quick step back to your pneumatic clamps. Do they have enough clamping force to allow you to mill using the pneumatic clamps, or is it typically for hole making?
Yeah, no, that's a good question. So now for the pneumatic clamps that I'm showing you here, these examples, and I've got some, I'm glad you asked, I'll show you here. So these are more examples of the pneumatic clamps. This is the one we have right here. So this is actually, the one I was showing you in the presentation earlier is a pneumatic clamp, which we only recommend that for light milling, but mostly hole making applications in tubing, pipe, things like that. This one now, this is a very similar for a 4th axis clamp, but now this has a hydraulic cylinder. So this one I would recommend for milling, heavier hole making, and just more aggressive milling applications. So you can see here, this has a 1-inch thick steel part in it, big hydraulic cylinder. But it's a good question because when we get into work holding, it's a pretty complicated subject. And that's why I think the customers, oftentimes they like us to turnkey the whole solution. So we not only build the machine, but we build the clamping, and, to suit their parts, just to make sure everything goes off without a hitch. But yeah, so if I'm just hole making, simple pneumatic clamps like this are more than adequate. This is just our universal pneumatic clamp. Has a pull pin here. This adjusts in and out, and there's a little toggle switch right here, if you can see that. And it strokes in and out a couple inches, and then that way I can just do simple clamping to hold channel, I-beam, flat bar, things like that.
That makes sense.
But yeah, for the heavier milling, I either have to use a machinist vise or I'm getting into hydraulic clamping such as this. I got you. Here's another, just as a great example of another pneumatic clamp. And this one's specifically set up for holding multiple parts, because that's a question we get a lot. So I'll place these along the machine bed, one here, one here, one here, one here, one here, and then I can hold 1, 2, 3, 4 parts inside of here. And we're able to accomplish that just using wave washers. So I think I can explode this a little bit. So you can see here, we're just using wave washers for each station just to compensate for any material deficiencies in part size. So, and that's how we're able to individually zone out those parts and hold, we call this the multi-clamp, just so I can hold 4 different parts at the same time.
Very good.
Did I answer your question, Brandon?
Yes, you did. Thank you.
Oh, good. So this is the double station pneumatic vise that we built. It's just a good example. And this one, we were milling with this application. Well, even in applications like that, what we can do is we overcompensate with how much the forces that we're going to be pushing onto the part. So like an example, I think it says it on the drawing, you know, we're 1,200 pounds per clamp of force. So we'll source it and make sure it's adequate. This is a nice example. This is a big clamp, so I don't have a dimension on here, but this thing is, I think it's 4 foot in diameter here, you know, end to end. And it was for one of our big gantry machines to hold the fixture plate for hole making. And again, here, so we were squeezing it, and I believe they're mostly just drilling in big plate. But it's pretty universal. You can see the examples. You know, I can set it up to hold angle iron. I can hold flat bar, channel. I can put an I-beam in here, just things like that. So this is the flex beam. If you can hear my child screaming in the background, I apologize. So this is a new machine. We're looking to launch this officially this year, but this is for our structural customers or fab shops looking to get into more structural work. This is it's a full turnkey machine, integrated hydraulic clamp to do your work holding, tool changer like you just saw, all the safety barriers to set up zones along the machine. But here I can accomplish milling, hole making, and you can see our pricing down at the bottom. We can offer a 50-foot long machine for $200,000 for our structural customers to do hole making, milling, like you can see in the video. And it just, again, gives them a lot of flexibility. And, you know, our shops that are currently plasming holes or using mag drills or manually drilling in some way, you know, with this machine, we can help them take it to the next level and really up their production and how competitive they are. That's our team. Other than that, guys, any big questions? Anything I missed?
How does the Flex Beam compare to the Ocean Avenger?
That's a good question. So the Flex Beam versus the Ocean Avenger, they're very similar machines. Price wise, I know we're better. Our service is great, and as is theirs, I'm sure. But no, ours is all in. So everything you see there includes the software you're going to need to import in a step file or to you know, a Tekla file or NC1 file. Training's included there, the tool changer, the minimum quantity lube through the spindle. It's one package all in. So, and that's where we're trying to simplify it for our customers and give them everything they need right from the beginning. So, and then they get us, they get to work with us. And like I said, we really like to pride ourselves that we're known for great service, and we're always going to bend over backwards to make sure our customers are making money with the machine. But I've got a drawing. So I showed you these. These are, I like to emphasize the clamps. Just, we get the question a lot, guys. So that's just something to keep in mind. If you want us to turnkey the solution for you, we can do that. This is the drawing of our gantry machine. I like to show this just to show off the construction a little bit, just so you can see how the machine's made. Here you can see the light barriers. This is how we zone out the machine. There's mobile light barriers on each end of the machine. Those move up and down the x-axis. And then here you can see the coolant tank. This is where the auger that runs the entire length of the machine. And the chips are collected here. The coolant's then recycled. But this is a model we can send everybody if you have any questions, or if you want to take a look at, you know, if you have any more questions about that. But this is a nice example too. This is a custom built machine. If you look here, this is one that we raised. We raised the gantry. Brandon asked earlier about height apart. Here we raised the gantry 6 inches, and we put double guides on the x-axis. So you can see these guides right here. To increase the rigidity with the raise of the gantry, we did double guides, and So there's nothing too far outside of the scope. If there's special requests or if there's some way we could build the machine to make it better for the customer, we can do that. And then I think here's just a two-dimensional of the beam line. Like Tyler had asked a good question, how does this compare to other machines in the market? One of the big points here that I like to talk about, this is just a 2D drawing, so I don't have the 3D model to share right now, but we guide, everything moves along precision linear rails, just like on our FlexCNC. So even on just like our VMC style, this machine moves along linear guideways, which is pretty unique compared to other machines that are out there on the market that, from a quality and durability of the machine, our machine's going to last forever, and it's nothing they have to worry about. You'll see that it's modular, so we can increase the length. They can build this machine as long as they would like. We typically are going to start out with 40 foot with a 10-foot extension. But if they want to continue adding extensions to give more lengths, we can do that. So this is just a quick snapshot, though, just to show the construction of this machine. The hydraulic clamp that's integrated with the head. This travels down the length of the beam, and the hydraulic clamp comes down onto the material just to hold it in place while we're doing any machining operation. Other than that, any other questions, guys?
Yeah, one more for me, kind of reverting back to your VMCs. We looked a lot about steel and, thick, very strong material. Talking about spindle RPMs, and what's standard? I mean, do you guys get into aluminum? What are your spindle options?
Yeah, like I said, so our machines are built to process steel. So that's what you can expect out of the rigidity and the strength. But no, a lot of customers, they look at our machine for the flexibility. So if we have a new option where we put in a 12,000 RPM spindle, and that 12,000 RPM spindle can process aluminum really well. But it's a nice spindle body, so it still has a really good torque output to process your steel material still too. So we have options, but so out of the box, typically 6,000 RPM gives the customers a lot of flexibility to run steel, aluminum, but still have a nice high torque output. But if somebody's looking for a little higher RPM, then we'll recommend our 12,000 RPM spindle option.
Okay, thank you.
How large of a hole can this drill? Like a standard carbon steel?
Yeah, that's a good question. So it's always a trick question, just because it depends what type of tooling I'm using. So remember in the presentation where I showed you that old Bosdick radial drill arm. If I'm using a machine like that and an old high-speed steel drill, that's going to greatly impact how big of a hole I can drill, because it takes a lot of torque to run those big twist high-speed steel drills. So if I'm using old tooling like that, the biggest hole I might be able to push is 2 inches. But using on our gantry series, we always recommend a Cat 50 spindle, and we'll put a ZF gearbox on there, and we're putting 400 foot-pounds of torque at the spindle. So with 400 foot-pounds of torque, I can, using a nice allied drill, I can make a 4-inch hole with this machine. And, anything past that, I'll interpolate it. I'll just use an end mill and circle mill it. Does that answer your question, Logan?
Yep, it does.
Good. All righty. Anything else, guys?
I think that's it.
Is that it? Well, I appreciate the time, and we'll talk soon. You guys call me if you need anything, okay?
Sounds good.
Thank you.
Thank you.
Thanks.
Bye.